Hello, I am Zheng Yuhao. Today I'm going to present my individual project, Trundle Wheel for Secondary Mathematics Learning, which is in Path 1 Product Design product. My presentation covers 5 parts: the project background and the rationale, the product concept, the technical design and the construction, its educational application, and finally reflection and the conclusion. The starting point of this project is a common problem in mathematics learning. Circular formulas such as C equal to 2 pi r are often taught in a very abstract way. Students may know the formula, but they do not always understand how circumference related to actual distance in real life. As a result, learning can become passive and focus only on calculation. So my project tries to bridge this gap by turning circle learning into tangible measurements and integrate STEM learning. This project is designed for Form 2 students and focus on the topics of circumference of circles. So in many Hong Kong textbooks, this chapter mainly presents formulas with limited opportunity for students to apply them in meaningful contexts. Therefore, I wanted my students to use STEM products to measure, record, compare, and interpret results in a more authentic way. This is the overall design of my trundle wheel. The main parts include the wheel disc, the microbit module, battery box, and the two-part handle. The process flow is simple. First, the wheel rolls. Second, the microbit counts the rotations. Third, the circumference formula is applied. And finally, the distance is logged into a file. The project reflects an integrated STEM design. In mathematics, the students use circumference unit conversion. In technology, they apply microbit coding and data logging. In engineering, they consider 3D product design, parts assembly, and structural stability. In science, they carry out field tests and evidence analysis. The mathematical principle behind this product is based on two main formulas. So first, the circumference formula, C equal to pi d, and the distance traveled formula, which is a number of rotations multiplied by circumferences. In terms of technical design, the mathematical principle is based on three key formulas. So the circumference formula, the distance travel formula, and for coding parts, the microbits use event-based control. Button A starts and stops the measurement. The log up gesture counts one valid rotation, and the debounce control reduces false counts caused by repeating triggering. Here is a completed coding. And this slide shows simple microbit data output. Here, each trial records data such as diameter, circumference, rotations, distance, and time, so which can later be exported to Excel file for comparison, visualization, and refinement. 3D printing is also an important part of this project. It's used to construct functional components such as microbits, module case, battery box, and the two-part handle. And the two-part handle includes support structure to help the 3D printing process. So 3D printing is not only for appearance, but also for function and the refinement. From a pedagogy perspective, this project can be applied through 5E model. In Engage, students face a real measurement problem. In Explore, they test the trundle wheel and collect data. In Explain, they account for the mathematical and technological logic. In Elaboration, they compare condition and refine the design. And last, in Evaluate, they interpret data and reflect on both product performance and STEM learning. So in conclusion, this project turns circles from an abstract formula topic to an authentic, measurable, and database STEM product. Although the prototype still has limitations in accounting accuracy and durability, It shows strong value for secondary mathematics learning by combining mathematics, microbit coding, data logging, and 3D design in one meaningful experience. Here is my reference. Thank you very much for your listening.